58. Determine the standard free energy change, the delta G notch formation, for the formation of S2 minus aqueous, given that the delta G notch formation for Ag plus aqueous and Ag2S solid are 77.1 kilojoules per mole and negative 39.5 kilojoules per mole respectively, and the solubility product for Ag2S solid is 8 times 10 to the negative 51. Wow, okay. So where do we go from here? Let's see. We want to solve for the standard free energy. So I'm looking for some type of delta G. And just know that when they're looking for a delta G F, F stands for formation. Now, when you're looking for a formation delta G value, you're only looking for one specific component of the balance equation. You are not looking for the total delta G. So whenever they're asking for a delta GF, that means that you're looking for one specific one. And it seems like we're looking for the S2 minus. But I have to write a balanced equation, right? Now they're telling us that the solubility product of Ag2S solid is 8 times 10 to the negative 51. Solubility products are KSPs. So I basically have to write a KSP equation for this reaction. Solubility products mean that you are always starting with your solid and breaking down into your two ions. So let's go with that. Ag2S, and that's the solid. This will, if you want to put double arrow to show that it's coming to equilibrium, because we're talking about K values, this comes to Ag plus, and that's aqueous, plus the S2 minus. And that's also aqueous. Let's just make sure that this equation is balanced. So I do see that I have two Ags, so I have to put a 2 in front of here. Now let's put down the delta G values that we have, right? The delta G value, and we'll say delta GF notch. They told me that the delta G formation for Ag plus was 77.1 kilojoules. When they say respectively, that means that whatever component they say first gets the first number out of the bunch. So the Ag plus goes with the 77.1, and the Ag2S gets the negative 39.5. Okay. And we're solving for the delta G formation of the S2 minus. So I'm just going to label this as X. All right, so ultimately, if we have individual delta G's and we want to solve for a specific component, chances are we're going to use this formula down here, right? The delta G of the whole entire reaction equals the sum of the products minus the sum of the reactants. But the thing is that I don't know what that delta G reaction is yet. I don't have the whole entire number for the whole entire reaction. I just have the individual parts. So I have to put this equation on hold because I have to find out that overall delta G. And that's where this formula comes into play. Because this delta G notch, that's for your overall reaction. And it's linked with a equilibrium constant. Now this K value, capital K, could be any K value. Could be a Ka, Kb, Kc, it doesn't matter. In this case, they gave you the KSP. So that's good enough for me. Golly, G. So K value is 8 times 10 to the negative 51. Do we know any of the other values? Well, we always know what R is, right? If we're using energy values, which Gibbs free energy, that's an energy value. This is 8.314. Units is joules per mole times Kelvin. So when I do find my delta G, it's going to be in joules, and the temperature has to be in Kelvin. But did they give me a temperature value? No, they didn't. But they gave me a little hint. I see notches all over the place. Notch values mean standard. So I'm using standard values, and the standard temperature is always room temperature. So that's 25 degrees Celsius. So just because I see that notch value, they're talking about formation reactions. It's at the standard temperature, 25 degrees Celsius. But I need to convert it into Kelvin. So let's just do that. But Celsius to Kelvin plus 273, or more specifically 273.15. So this would be 298.15. And now I have everything to solve for my delta G for the whole entire reaction. So let's see, negative. I'm going to just insert the K value first. 8 times 10 to the negative 51. We have the R value of 8.314. And we have the temperature value of 298.15. Let's find out what that overall delta G is. So the overall delta G is negative 8.314 times 298.15 times the ln of 8 times 10 to the second comma. That E button means times 10 to the, and then I put negative 51. I could close the parentheses, press enter, and there you go. So let's just say 285,938. And that's in joules, right? Joules per mole, or just joules, because the R value said only joules. However, these values were in kilojoules. So before I go into my next formula, maybe I should just convert to kilojoules. Easy enough, right? Joules to kilojoules, I just divide by 1,000. Or I could take the decimal, move it over to the left 3 spots. So I have 285.938 kilojoules. And that's now my new delta G reaction value. All right, so now let's maybe move this over here, because now I'm going to use this formula to solve for, maybe I'll bring this down a little bit. Oh boy. Hold the phone. Okay. So now I know my delta G for my whole entire reaction. It's the 285.938 kilojoules. But now the sum of the delta G, right? Sum just means you just got to add them all up, right? You got to add all these up minus the sum of the products. But when you do this, you always have to take into consideration your coefficients, right? There was one Ag2 solid. So I take that number, negative 39.5, times it by 1. There was 2 Ag pluses. So I take that value and times it by 2. 1 S2 minus, so I take that and times it by 1. Sum up the sides that have multiple compounds or substances, Ag plus S minus, right? So these two numbers should be added together. You don't have to add this side up because there was only one substance. So this whole side would be 39.5. And now this side, well, it would be 77.1 times 2. 154.2 plus X, right? You string in the X along. Products minus reactants. This equals the sum of the products, which was 154.2 plus X minus reactants, which is negative 39.5. All we got to do is just solve for X, right? So I could just simplify these two values. 285.938 equals 154.2 minus a negative 39.5. So I get 193.7, and that's plus X. So now just solve for X, right? Minus 193.7 minus 193.7. This cancels. Now you're just left with X. So 285.938 minus this answer, And there you go. Maybe we'll do 3 sig figs. So 92.2. Units here would be the same delta G formation for the other ones. So kilojoule per mole. And that's it. So your delta G formation for the S2 minus is 92.2 kilojoules per mole. And that's it. Not bad. What'd you think? Let me know in the comments. Hopefully this helped. Thank you so much for viewing the video. Thank you for being part of this cool community. Yeah, let's keep learning. Let's keep studying hard. Good luck on your tests and quizzes. And I will all talk to you in another lesson. And yeah, that's it for me. I'll talk to you later. Over and out. Bye-bye.